Hi, my name is Sean, and today we're going to be learning how to write and say very large numbers, as well as an introduction to scientific notation, decimal small point numbers, and eventually we're going to calculate the size of the Milky Way. Alright, so like I said, today we're going to be learning how to write large numbers and how to calculate the size of the Milky Way. First of all, large numbers can be written one of two ways: scientific notation and long form. So as you can see, scientific notation has the amount of zeros in the 10 to the amount, and then long form has the number of decimal places, with the decimal point being the solid line, and it's written out in long form. So making all this possible is the concept of zero. It is both the mathematical equivalent of nothing as well as what allows very large and very small numbers to exist. Expanding further, zero could be considered the opposite of infinity, nothing expanding nowhere ever as compared to infinity, which is everything expanding everywhere all the time. What do we consider massive? For most practical things, anything above about 10,000 is quite a lot. Like you can see, zeros are grouped in slides of 3. Essentially, the more groups of 3 you have separated by a comma, the larger your number is. However, for decimals, zeros expanding to the right, this rule does not apply. Notice there is only one period for very small numbers, whereas there can be any multiple of commas for very large numbers. So there you can see that there's only one period for very small numbers and groups of 3 zeros, like you can see here, 1,000 and 100,000 for very large numbers. So zero will act primarily as a placeholder for nearly all of this lesson. How to write out scientific notation is separate and applicable, and we will get to other abbreviations later. Just so you know, the whole purpose of scientific notation is to avoid having to write out these zeros in the first place. For pretty much anything today, anything below a million, 9 zeros or 3 groups of 3 is small, relatively speaking. We'll start our journey to the stars and calculating the size of the galaxy with 100,000s. Like the number 1,000 or 10,000, 100,000 has one comma. Every group of 3 zeros has a comma separating it. Next, the 1 millionths. 1 million has 6 zeros in it. It literally means in Italian 1,000 hundreds, where mille, M-I-L-L-E, means 1,000, with the suffix 1 meaning 100. To give you a sense of scale, 100,000 is only 10% of 1 million. 10,000, our baseline a lot figure from before, is only 1% of 1 million. You can fit 100 groups of 10,000 into 1 million. According to 2005 data, 336 cities worldwide have over a million people. Only 10 U.S. cities have a population of over 1 million, while over 100 do in China. To say or write numbers that are between thousands, you add 1 zero for every tens place. Said another way, multiply 10 times 10 to get a number with one more zero up to 2 zeros, and then on the third one you will need a new comma. Notice that 1 million and 100 million both have only 2 commas. To put things in context, only the top 2 or 3 cities have populations over 10 million on Earth. With 2017's data, less than 15 countries have population over 100 million. Which, as you can see, the scientific notation is there as well. Here's where things start getting a little bit crazy. A billion, that's with a B, has 9 zeros. That's one more group of 3 zeros than a million, which means one more comma. And this makes sense because a billion is 1,000 million. Remember 10,000? There's 100,000 groups of 10,000 in a billion. I won't write out 10 billion and 100 billion, but to get those numbers you do the same thing as I showed you with a million. Times it by 10 and add a zero for each number according up to 3. A trillion with a T has 12 zeros. That is 4 groups of 3 zeros. So 1, 2, 3, 4. Unless you are talking astronomically, and in addition to many other fields, billion and trillion are rarely used. You may have heard about that multi-trillion-dollar asteroid made of platinum. Some space rocks for theoretical asteroid mining could be worth trillions based on the elements they are composed of. Here on Earth in particular, aptly named rare earth elements have a surprisingly large role in playing in many economies, particularly in those of computing and consumer technology. As of 2014, the global GDP, or the economic output of every country on Earth put together, is $77.83 trillion in US dollars. So a side note about trillion versus billion. The American billion is 10 to the 9th, or the billion mentioned above. The European billion is considered to be American trillion, or the 10 to the 12th. Europeans say 1,000 million or milliard for the American billion. So after a trillion, number usage falls off a cliff. You can see a chart here documenting the different kinds of illions, but primarily they're the prefix followed by illion. So if you notice, these are all number-associated prefixes, and the reason they're associated with that number instead of the one number before is because if you remember, trillion was 3, and million was technically 1, but in this case it was counted as 2. So that's why you see 4 instead of technically it's 5. So essentially, for numbers over a trillion, use the prefix and go from there. So you've probably heard a few aphorisms when people try to humorously say a lot or are intentionally looking for use of hyperbole. Centillion, which is 1 with 303 zeros in American notation and 1 with 600 zeros in European notation. Or Google, which is actually not spelled like that, it's spelled Googol, is 1 with 100 zeros, also known as 10 times duotrigontillion in American notation. So that would be 1 Google is 10 times this amount. Finally, a Googleplex is 1 followed by a Google of zeros. This is far larger than any other numbers that we have shown. So here's, like I mentioned, in astronomy primarily, billions and trillions are pretty common actually. So let's try and solve our original question. Light takes 8 minutes to travel from the sun to the Earth, a distance of 93 million miles, and it also takes 1.2 to 1.3 seconds to travel the distance from the moon's surface to Earth, or about 350 to 400,000 miles. 1 light year is approximately 9.5 trillion kilometers, or 6 trillion miles, and it is a measure of distance, despite the presence of the word year, which can be confusing. The closest star to the sun is Alpha Centauri at 4 light years away. That means when you look through our telescope at our stellar neighbor, you are looking back into the past by about 4 years. Our home galaxy is about 100,000 light years across, which, like I said, is a measure of distance, not time. So simply multiplying, you get 9.5 times 10 to the 17th kilometers, which equals 950 quadrillion, or 950 with 15 zeros after it, which is equal to 9.5 times 10 to the 17th. Now you have a better way of understanding large numbers as well as an introduction to decimals and scientific notation. You also know the approximation of distance from edge to edge of our own home galaxy, the Milky Way. Thanks for watching.